Hello, I still remain your tutor, Prince Obajowo Daniel De Nicole, also known as the Mathaholic Arithophysical Biologist. So let's solve this problem together. Considering the diagram we have above, the question says that a block of mass 0.5 kilograms is suspended at the 46 centimeter mark of a light meter rule AB that is pivoted at point E, the 90 centimeter mark, and is kept at equilibrium by a string attached at point D, the 60 centimeter mark, as shown in the figure above. Find the tension in the string. Take G equals 10 meters per second square. So what you need to do is you redraw the diagram to suit what you need. Now, looking at this question, we are asked to calculate the tension. Now, if you look at the tension is inclined at an angle 30 degrees to the horizontal. Can you see that? So we can use this inclined tension to solve this problem. Remember, to solve this kind of problem, we need to take moments about a particular point. And this moment must be vertical in this case. So, which means that will take us to computing the vertical component of this tension. Can you see it? The vertical component. Now, how do we compute the vertical component of this tension? Remember, you can equally draw an imaginary line here to form a right angle triangle, as you can see it presented here. On that note, looking at that, this angle is facing this side. On that note, it is what? The opposite side. Can you see that? Then this place is the hypotenuse side. On that note, since we are looking for the tension, we can actually make use of this and this. That is sine theta equals to, or sine 30 equals to, let's call this y. Are you get what I'm saying? All over t. Now, making y subject of formula, that will give us t sine 30. And this particular side is equivalent to this side. I use this side because this side has a particular point. That is, we know the distance between this point A and that particular point D. Can you see that? Now, going back to the diagram again, we have been told that the mass 0.5 kilogram is at point 40 centimeters. That means from A to C, we have 40 centimeters. Can you see that? Then from C to D, or let's say point D rather, is on 60 centimeter mark, which means to obtain 60, we subtract 40. Or we had 20 to 40 to get 60. So that means the distance between C and D is what? 20 centimeters. Can you see that way? Now, looking at the other part, we have the pivot at 90 centimeters, which means the distance between point D and E is what? 30. So if you add 30 to 60, you have what? 90. So that's why I have 30 centimeters here. So having successfully put the parameters needed, the next thing is to take the moment about the fixed point, which is what? Which is the pivot. So considering t sine 30, which is the vertical component of the tension, to the pivot, we have that to the clockwise turning moment. Now, considering the mass 0.5 kilogram to the pivot, that is the anti-clockwise turning point. So let's take the moment about E. Taking the moment about E, we are going to have t sine 30 times the perpendicular distance, that is the distance between that t sine 30 and the pivot, which is what? 30 centimeters. Can you see it? Equals to 0.5 kilograms times the distance between 0.5 kilograms and the pivot. That's 20 centimeters plus 30 centimeters. That's what's 50 centimeters. So if you simplify that, sine 30 is 0.5 or 1 over 2. If you multiply 0.5 by 30, you have 15. Multiply 0.5 by 50, you have 25. On that note, we have t times 15 centimeters equals to 25 kilograms centimeters. So since you are looking for the tension T, we divide both sides by the coefficient, which is what? 15 centimeters. Doing so, we have T to be equals to 1.6667 kilograms. But then, tension is a force, which means we need to obtain our tension in newtons. So that will make us to multiply the tension by, or the mass by acceleration due to gravity G. So if you do that, we have 16.67 newtons.